again, it is super important for you to be able to identify the variables and understand clearly what they mean. Lots of times you can get hints from the wording. If you read it and you realize there's a rate of change, that will lead you towards what the two variables are, right? If we read it, we say you receive $100. Then each week you add $5 to the account. That statement, the rate of change for that account is $5 per week. Can you understand that from the wording? Can you pull that from the wording? $5, dollars is one of the units, right? The weeks is going to be one of the other units or variables. $5 per week being your rate of change. Yeah. So in terms of which one would be our X variable? Weeks or time being on the x-axis being our independent variable. And our cost, or our dollars in the account, okay, is our y variable. So a lot of you guys, I saw you were able to pull out the slope being $5 per week, and it's a positive 5 because we're adding. In the wording, in the context of the problem, we're adding that per week. So that's a plus. The y-intercept in this situation is our start spot. We're told that we start at $100. So this ordered pair is actually going to be 0, 100. And then in terms of our equation or our model that we're going to use, we can, when we have a y-intercept and a slope, we can put it right into slope-intercept form. Okay? Make sense, guys? All right. Use this equation to solve the equation when you have to figure out how long it takes to get $310 in there. Would 310 be an X or a Y in our equation? Yeah, if you are having trouble deciding that, go back to the definitions of your variables up above, and that'll lead you to that, right? Our Y is going to be 310, and we're going to take that and put it into our equation. And we're going to solve that equation for X. And remember what X is? In the context of the problem, X was weeks. So we'll get what we need. We're going to minus 100. Can one of you guys tell me what 210 divided by 5 is? 42. Okay. Now that's our answer for X, but is that the answer to the question? Recall from yesterday, we take the context of the situation, we strip that away and put it in symbolic notation. But at the very end, we need to put the context back on the situation. 42 weeks of deposits. So if you were like me as a high school student, you'd be like, why do I have to write that? Right? Because you're like, that's silly, that's redundant. Well, it's a representation that you are understanding the actual context of what that number is. Okay? You need to put it back into context to demonstrate you understand the meaning of that number, not just the fact that you got a number. Very often, half of the students will just put a number if I just let you put a number, but they don't know what that number actually means. And a lot of times if you make a mistake, so if I would have said the answer was 2 weeks, through the calculations we got 2 weeks, and you stopped it and you thought about that, that makes no sense in the context of the scenario, right? You're not going to go from $100 to $310 in 2 weeks by putting in $5 a week. That makes no sense. So it'll give you an opportunity to reflect back on whether your values actually make sense. Let's look at our next scenario, 3. We have an average rate of $3 per day, 15 days, he has $65 left. The amount left depends on the number of days that have passed. Okay? Variables, define them, please. What do you guys say to be our X variable? This anonymous person said something about days. Days passed. Or days of spending. Yeah. We won't put 14 in there because we want to keep it generic. Okay, we don't want to specify to a specific day. Amount left. Amount left in the account. No, you said amount left. Or you said amount in the account. You said amount in the account. He said amount left. Both of which in the context kind of make sense in terms of what we're talking about. They're almost equivalent. I just put both of them together. But we need to talk about our amounts in dollars or, dollars. So do we have a y-intercept? Do we have a start value in this? Do we have a slope? There's no start value. It's not like, oh, we started with this amount. Eventually we could, yeah. So, but is there a slope? Is there a rate of change? Is it a +3 or -3? We're spending, right? We have to talk about the context with these numbers. Spending, so it's negative. Do we have a point? Do we have a pairing between the amount of days spending and amount left? 1468. Not 14.3, just because they were close to each other. 1468. Days was X, dollars was Y. So write an equation or a model for this situation. We have a slope and a point. We know how to write equations of lines with slopes and points. We use point-slope form, right? If you're caught there, you can use your flow chart and look at, oh, I have one point, and then I have a slope. Follow the flow chart to see where we go. So we distribute -3, and that would be 42. And then we kept solving it, plus 68. Why do we keep going? If you look at the flow chart, there's a statement that's like where to end. It says, if I don't specify, I want you to leave it in slope-intercept form. 110. Plus 110. That's our equation. Use your equation to find the amount of money he will begin with. We have more context to this. We're not given a specific number here, are we? We're not even given which variable is which number. It's not very obvious. Begin with. So the start. At the start, which represents how many days? Let's start. How many days? 0, 0. So X is 0. If you want to do it the hard way and you actually want to put it into the equation, you can. But if you're thinking about what this 110 actually means, right? Remember that's the y-intercept? Remember y-intercepts, we talked about the start value? And then you were real close to saying we can find that start value. Well, we did when we put it in the equation, didn't we? So 110 was our start value, $110 at the start. In the account at the start, you could be more specific. Okay, I want you and your little group there, the folks around you, so in front of you and behind you, I want you to take a look at, let's skip 4. I don't like 4. We're gonna skip 4. Let's do 5. So we've got 2 variables. We have the first variable being minutes of the phone call, or minutes talking, and Y is the cost of the call. in terms of dollars. Now there's 2 points in this. One is 5.91, and one is 10.86, because those are paired up in the description. And then from that, we can actually get our equation, which that is what this is. This translation says write the equation of it. To write the equation of a line using 2 points, we need to get the slope first. So we calculate the slope. So after you set it up where you get the 2 points, we want to write the equation of the line. That's what that statement, that question actually says, translated in terms of the context. To do that, we have 2 points. To write the equation of the line using 2 points, we first find the slope, and then after we find the slope, which is 0.99, and it's okay to leave it as a decimal. After we find the slope, we can put it in point slope form to calculate it. So I'm going to use the first point. And then we can continue. When we distribute, what's 0.99 times 5? Anybody do it? What's 0.99 times negative 5? What is it? 0.99 times what? 5, negative 5. Negative 4.95. Y minus 5.91. And then we're going to add, right, 5.91 to both sides. And we get y equals 0.99x plus 0.96 as our equation. Yeah. After we do that, then we look at our next problem and we put it back into context. How long can you talk on the phone if you have $12 to spend? That is your cost, y. On B, we don't put anything in for x because x is minutes. We put something in for y because 12 is dollars and y was dollars. So you get 12 equals 0.99x plus 0.96, and you solve it. 0.96. You get 11.04, and then you divide by 0.99. And you get approximately 11.15, and we've got around it. So that would be 11.15 minutes of talking for $12 in terms of this pay rate. That's an expensive phone call, for sure. What the heck? So the question is, if it costs 99 cents per minute and you're only talking for 11 minutes, 15 seconds, shouldn't it be less than $12? Right? That's the question. Yes, if there was no starting cost. So because the original situation tells us that gives us two different dollar amounts for different sets of minutes, at 0 minutes in this situation, it costs 96 cents. Like there's like a base starting value of this. Does that make sense? So you start by paying 96 cents just by turning on the phone. And then after the first minute, it's 96 cents plus 99 cents. That makes sense? So it's a little off. That was a really good question. Way to analyze it. So, a little higher level thinking there. Go ahead and go ahead and look at number 6 and try to take care of it. I'm going to propose some questions to you in terms of these variables. Remember, we have to have our conversation with the independent and dependent. When you read it, you probably saw chirps per minute, and you're like, that's time. Did you guys think that? That's not really time, okay? Or you might have read chirps per minute, and you might think slope or rate of change. That's not really the rate of change that this problem is going. In the context of the problem, there's two things that are changing, temperature and the amount of chirps, right? Does that kind of separate things a little bit, simplify things, two things are changing: temperature and chirps. Okay, so let's put that into terms of independent and dependent. Okay, if the amount of chirps, if there's a cricket and it's chirping a bazillion times, okay, if the amount of chirps goes up really high, is the temperature affected by that? Is the temperature outside going to change by a bunch of crickets chirping a bunch of times? Okay, is the temperature going to force the crickets to chirp more or less? Which one is the answer? And that'll lead you to what's the independent and dependent. The temperature is what changes that forces the chirp change. That make sense? So the independent, the one that forces the change, the one that changes the other, is the temperature itself, not the chirps, because it would be silly for a bunch of crickets to make it really cold or really hot outside. That just doesn't make sense when you talk through it. So our X in this scenario is the temp, degrees Fahrenheit, and the Y is amount of chirps. Excuse me. Per minute. So did y'all get that we're going to have 68, 124, and we're going to get 80, 172. And after we do that, we can write the equation. 172 minus 124, 80 minus 68, and you get 48 over 12, which is 4. Yep. And then that's our slope, but we got to put that in point slope form to get our actual equation. So we drop that in for the slope in point slope form, and I'm going to use the point on the left, 124, 68. I'm going to distribute and simplify. What is 4 times 168? Am I get that?
It's 408, negative 408.
It should be. It's not. The slope is 4, not 6. You'll get 408 if you use the slope as 6. 4 times 68 is going to be 272, and then we're going to add 124 to both sides. So minus whatever that is subtracted. What do you get that as when you do negative 272 plus 124? Negative 148. And then that's our equation. And in terms of X chirping, or in terms of B, 150, is that our Y, or X? That's our Y. Because that was chirping. If we look up in our variables, we can determine that. So 150 equals X minus 148, and then we can solve that. Add 148 to both sides. You get 298 equals 4X. And when you divide by 298 by 4, you get, what do you get? You get 70, what do you get? 70 what? I think 74.5, is that right? 298 divided by 4. 74.5. And then in context, 74.5 degrees Fahrenheit. Peace.